Hey guys, it's Miss Pasenka. If you are just watching this instead of being on Zoom, that's perfectly fine. But make sure that you check in with me to get your attendance for the day. So we already did 1.3 part 1. Now we're doing part 2. If you did not upload your notes and homework from part 1, please do that before going on here. So first we're going to have a warm-up. These are your questions. Go ahead and do them. Pause your video and do those questions before you get started. Do not just go on to the answers. So pause your video and do them. So for numbers 1 through 3, I have the answers written down here. Draw an example of each. Point A, so we just do our dot in the capital letter A. Line AB, you could just have your line like the one shown, or you could also do B here and A here. For the other one, for number 3, that is array. So the two options that are listed there are what you can use. Here are the answers to numbers 4 through 8. So, what are two other ways to name line QX? Okay, so first of all, you guys have been in class or listen to the notes. So line S is a way to name line QX because that little lowercase is an example of the whole entire name of the line. We can also do line RX or we can do line RQ. You could also do line XQ or you could do line QR. It does not matter that the order that you put those in. You just have to have 2 points to name it. Number 5, what are two other ways to name plane? RSQ. So again, in class or on the video notes, if we don't have a point by that V, that means that it is there to name the whole entire plane. So that is why we use this answer here, plane V. We can also name it using any of the other points on or in the plane. We cannot use these guys here because they're lowercase and they are not a point. They name those specific lines. So check your answers with that. If you have a question on that, just let me know. Name 3 collinear points. So we are looking for points that are in a line. So the only example here that we could use are the points R, X, and Q because they all lie on that same line. If we use this line here, there's only 1 point on that line. So the only ones that we can name 3 collinear points is the RXQ line. Number 7, name 4 coplanar points. So you have to pick a letter that, whoops, that's too dark. You have to pick a letter that is actually a point. So V, S, and R are not points. So you have those 4 points to choose from. And obviously that's the answer there, R, X, Q, and Z. It does not matter the order you put that in. Number 8, so name a pair of opposite rays. You could technically, well, actually you cannot because we don't have any other letters here to name those rays. So the only options that you have are the ones that are given. So we have XQ and XR. So XQ is one ray, it goes that way. XR goes the other, and they share the same endpoint there. So that is our opposite rays. Okay, congruent segments and segment lengths. So if we have 2 segments having the same length, their measures are equal. So if we have a line that equals 10 and another line that is the same length, that measure would also equal 10. And I want you guys to write this down on your notes if you're at home. So that means that we are using an equal sign. Okay? If two segments have the same length, then the segments are congruent. So look at the difference here. We have their measures are equal and segments are congruent. Okay? So they are a little bit different there. When we use an equal sign, that means we're using numbers. When we're using a congruent sign, that means figures. And a congruent sign looks like this. Make sure that you know the difference between an equal sign and a congruent sign. With an equal sign, you are using numbers. So let me do this here. Or rather do this. Equal sign means numbers. And a congruent sign, whoops. And a congruent sign means figures. So if you look at our little, our diagram here in the box, so we have AB equals CD here. So that means AB is 1 inch, so CD has to be 1 inch. For congruent, we use, let me use this instead. We use these fancy things here. These tell us if objects or diagrams or figures are congruent or not. Sometimes they're only going to use one little tick mark. Sometimes there will be 2, sometimes there will be 3, depending on how many figures you have that are congruent. Okay, so let's practice with congruence here. So does AB equal CD? So you need to see, does AB's length or distance measure to CD's distance? So if I'm looking here, AB is from here to here, and CD is from here to here, right? So are those distances the same? So from A to B, we go from -2 to +3. So think back to our notes from Thursday and Friday, or actually from just a little bit ago, the segment addition, no, the ruler postulate, sorry. So AB equals CD, so we can either use our, if we go from -2 -3, and then we take the absolute value of that, we would have the absolute value of -5, which means AB equals 5. We can also just count. So for C, we start at 5, then we go to 6, so we go from 5 to 10, which would also be 5. So that means AB does equal CD, so 5 equals 5, so we would have yes. All right, on to the next one. Is line segment AB congruent to line segment CD? Okay, we know that 5 equals 5, right? So they are congruent because AB already equals CD. And if those two equal each other, then we know that they are congruent. Number 3, find BD and AC. So if there's no little line above it, we are finding the measure of it, or the distance. So go ahead and try it or count along with me. So BD is from here to here. So I go from a 3 to a 10. So that means that BD equals 7. Okay, and then we're going to do AC. A to C. So I'm going from -2 to 5. So between -2 to 0 is 2, 0 to 5 is 5. So 2 plus 5 is also 7. So AC also equals 7. If they are the same measure or the same distance, they are congruent because the two line measures equal each other. Okay, is AB congruent to ED? All right, so let's look here. So AB goes from -2 to 3, and we already know from up here that AB is 5, okay? And then ED, we haven't found that measure yet, so ED is from here to here, 10 to 14. So that means I'm going 4 units in between. Does 5 equal 4? No, it does not, so these cannot be congruent. They have to have the same, can't fit it there, they have to have the same distance or measure for the line segments in order to be congruent. Okay, so the last one, this is a little different than what we did earlier. So if we want line segment FD to be congruent to DE, okay, we first need to find out how much is DE. We know from the above question that line segment ED or line segment DE is 4. The measure is 4. So we need to draw FD to where that line segment FD or DF equals 4 as well, because we want the two line segments to be congruent. So that being said, I would need to, so if I have FD, so I need 4 measures, like a measure of 4 in between F and D. So if I have D at 10, that means I need to put F at 6. That kind of looks like an I. Need to put F at 6. So that would make them congruent because FD is 4, DE, the measure of DE, the measure of FD are both 4. It has to be 4 units long. Okay, next one. Use the number line below for exercises 6 through 9 and tell whether the segments are congruent. So GH and HI. So what I do is I just look at how many units are between the two numbers. So for GH, I have -10 to -6. How many jumps or how many units are between each point? So from -10 to -6, you are going 4. For HI, line segment HI, we have -6 to -2. Whoops, I wanted a different color there. -6 to -2. That also is 4. Why did that not go? Because both of them are equal, GH and HI are congruent. The line segments are congruent. Okay. For number 7, GH and IK. So from the previous problem, we already know that GH is 4. Now we need to look at IK. I to K. -2 to 2. So from -2 to 0 is 2 units. From 0 to 2 is another 2 units. So 2 plus 2 is 4. Yes, they are congruent. Okay, now moving on to the next one. Most of the time you guys will be able to use a previous answer in like the next one, so make sure that you're not doing more work than you need to be. So for number 8, we know that IK is 4. We need to figure out what HJ is. HJ is from here to here. So from -6 to 0, that is 6 units. So does 6 equal 4? No, it does not. So these two line segments are not congruent. Number 9. Whoops. Number 9. Neither of these ones we have done, so we have to do new measures here. So from I to J, whoops. From I to J, -2 to 0. How many jumps do we make there? I to J would be 2. Whoops, dang it. J to K. Now we're looking at J to K. I did not want to make that black. Sorry, guys. J to K is from 0 to 2. So J to K is also 2 units. So this would also be congruent. All right, on to the next one. So, midpoint. Midpoint is the point that divides the segment into 2 congruent segments. So get that written down. You can pause it if you need to. An example would be A is the midpoint of BD. So I want you guys to draw this example on your page, okay? Oh geez, that is not a good straight line. Okay, so 2 congruent segments. We know that line segments have endpoints, right? So we have B and D. A is the midpoint of B and D. So we would want to draw A as much in the middle as we can, okay? And if it tells us that it is the midpoint, that means this line segment and this line segment are congruent to each other, because A being the midpoint divides those 2 segments into congruent segments, okay? So if they're congruent, that means if BA is 5 inches long, AD would also have to be 5 inches long, okay? And then BA is congruent to BD, which also means that BA equals dang it, my bad. This should be an A, I'm reading the wrong thing. This should be an A, and this should be an AD, because the 2 congruent segments. And if the 2 segments are congruent, they also equal each other. If you need some more time to write that down, pause it and then move on. A segment bisector is a point, line, or ray that divides a segment into 2 congruent segments. So, for example, line XY bisects line segment AB at point M. So, take a second there to write it down, okay? So we have line segment AB, okay? And then we have XY bisects. So that means it's in the middle of that line segment because it is breaking it into 2 congruent segments. So try and put it in the middle as much as possible. Obviously, it doesn't have to be perfect, but don't put it, don't put it over here and then say that they're congruent, because that's not pleasing to the eye. Okay, so going back to here. So I'm going to try and put it as much in the middle as I want. You can make this line however you want, but it has to bisect AB. So obviously it has to be horizontal. It needs to go up and down, or sorry, it's obviously vertical. It needs to go up and down, but you could have it slanted. You could have it at a, straight up and down. You could have it slanted the other way. It doesn't matter. And then we want to make sure that we label our line. And then where that line XY bisects line segment AB is point M. So we need to draw that as well. Then, okay, we know that these, that's a bad color. So is that? Dang it. Hold on. Okay. This is just something else right now, guys. Okay, that's better. All right. So, what was I saying? We need to put congruent marks there to show that both of these are congruent, okay? You do not need them on the line because lines extend forever and ever in both directions. So we just have them, and we don't know for sure that AB, line segment AB, bisects the line XY. We know that it bisects AB, line segment AB. Okay, so now on to number 10. So Q is the midpoint of line segment PR. What are PQ, QR, and PR? So be careful here. This means that we are looking for the measure or the distance because there's no line on top of there. Okay, so we need to get an actual number. All right, now that being said, if Q is the midpoint of PR, that means that this is congruent to this. PQ, oh geez, PQ is congruent to QR, okay? So that being said, let's think back to Algebra 2 or Algebra 1, right? We have PQ and QR being congruent. That means that PQ equals QR. So if we know that PQ equals QR, how can we solve this problem to figure out what PQ, QR, and PR are? We need to solve for X. So if we know that PQ equals QR, we can set this up as an algebraic equation and solve for X. So we'd, subtract 5X from both sides, bring in back some algebra here. And then we would want to, whoops, I don't want to write that, I want to write that. Then we would add 7 to both sides, and we would get X equals 8, okay? So now that we found X, we can plug that in to find PQ, QR, and PR, okay? So here's the thing about this. If we know that PQ is equal to QR, we only have to plug in X one time, okay? So I'm going to plug it into PQ first. So PQ equals 6 times 8 minus 7. 6 times 8 is 48, and 48 minus 7 is 41. If we know that PQ equals QR, that also means that QR is 41. And we know that PQ plus QR equals what PR is, which would be 82. Okay, so if you need to replay that slide, go ahead and do that. Take your time, get all this written down. Number 11. This is going to be very similar to the one that we just did. So you guys go ahead and try this one. Pause the video if you're at home, and then I will go over it with you. So we know that these two are congruent, right? So if they're congruent, that means that they also equal each other. So ST is congruent to TU, so ST also equals TU. So that being said, we have x's, like the last one. We need to find what x equals first. Okay, so I'm going to do that first. So I have 3x plus 3 equals 2x plus 9. So I'm going to subtract 2x from both sides. I get x plus 3 equals 9. And then I'm going to subtract 3 from both sides, and I get x equals 6. So now that I know x equals 6, I can just plug it in for a, b, and c to find those answers there. Some of them I'm not even going to have to plug in because I know with these theorems and postulates that I can do less work here. So if we just find ST first, right? 3x, or sorry, I don't want to do the x. We're looking for the measure of this. So remember, if there's no line on here, we're finding how much it equals, the length, the distance. So 3 times 6 plus 3. 3 times 6 is 18, and 18 plus 3 is 21. We know that ST equals TU, right? So the next one, B, is asking us to find TU. TU is also 21. If you want to plug it in and just double check, 2 times 6 is 12, and 12 plus 9 is also 21. Then, think about the last one we did. If we're finding SU, which is the whole entire thing here, all we're adding up is ST, which was 21, and TU, which is 21, to be 42. All right, so now we have a couple of, this is what I was talking about in this diagram with the different tick marks. So RO and OQ are congruent to each other. NO and OP, line segment OP, are also congruent to each other, but they are not congruent to each different set. So like the two green ones are not congruent to the two yellow ones. You have to remember that. If they have different tick marks there, they are not congruent to everyone in that diagram, just the ones that they are matched to. Okay, so for number 12, if RO equals 6 plus x and OQ equals 2x plus 1, find the value of x. So I know that, let me erase this here, so we're only working with the 1. RO is 6 plus x, so I'm going to write that down. Whoops, don't want that fat marker there. Okay, 6 plus x. And then OQ, so the other side of the line segment, is 2x plus 1. Because they are congruent, they can be set equal to each other. And then you guys know what to do, so solve for x. So subtract x, we got 6 equals x plus 1, and then subtract 1. So x equals 5. Okay, now that being said, we can go through here and figure out what our measures are of these three things. And again, just do it once because most of the time your first answer is going to help you get the next answers. So RO, the formula there, or the equation, is 6 plus x. So we're going to plug in 5 for x. Whoops. We have 6 plus x. So we have 6, and then we're going to plug in 5 for x. So RO, the measure of RO, is 11. Now you guys know that RO also equals OQ. So OQ is also equal to 11. And then it's asking us to find RQ. So that is the whole entire line segment. So RQ equals 11 plus 11. So we're adding both of these guys together, and we get 22 for our answer for that one. The next one, so we are working with just the 2 tick mark line segments, okay? we know that ON is 5x, so this one we might want to draw a little picture too, okay? Whoops, didn't want it thick like that. Okay. We have N, we have O, whoops. We have N, we have O, and we have P. And we know that they are congruent to each other, both of the smaller line segments. So we know that ON is 5x, and we know that NP, the whole thing, is 40. So think about math here, guys, okay? If NO, if ON or NO, however you want to say it, dang it, is congruent to OP, that means that the measure is the same. Now you can do this a couple different ways. So if ON is 5x, that also means that OP is 5x. So in order to find x, we can just set it up as an algebraic equation. 5x plus 5x equals 40, because this one is, the first one is ON and the second one is OP, the measure or the length of it. So 10x or 5x plus 5x is 10x. And then we need to divide both sides by 10. So x equals 4. Okay? Now it's just asking us to find what is the measure of ON and OP. So we're just finding the line segment measures, because we already know the whole entire line segment. So that being said, you could either take the easy route and say 40 divided by 2, because we know that both line segments have to have the same measure, or we can plug it in and say, okay, ON equals 5 times 4, so ON equals 20, and then we know that ON equals OP, so OP is also equal to 20. Okay? So if you guys have any questions, make sure to email me or post it on Zoom or ask questions through Zoom. And make sure to post these completed notes through Canvas. There will be your section where you can upload your notes. Again, if you have any questions, let me know. Thanks, guys. See you soon.